We're now going to start with trigonometry, which hopefully you remember from last year is the study of triangles and the relationships between the sides of the triangles. Before we look at the trig functions, we need to remember how to name the sides of the triangles. We're working with a right-angled triangle, so the easiest one to name is the one opposite the right angle. That will be the hypotenuse. In this slide, I'm going to be talking about angle A, which means the side opposite angle A is BC. So we're going to talk about the opposite side. And then the one next to angle A, we're going to talk about the adjacent side. Now, if you look at the relationship between the opposite side and the hypotenuse, we will be working with the sine function. And sine can be abbreviated to sine A is equal to opposite over hypotenuse. If we look at the relationship between the adjacent side and the hypotenuse, we're working with the cosine function, which we can abbreviate to cos A is equal to adjacent over hypotenuse. And if we look at the opposite side and the adjacent side, we're working with the tangent function, which we can abbreviate to tan A is equal to opposite over adjacent. And SOHCAHTOA is a lovely way to remember which sides work with which trig function. Now last year, after looking at the triangle with sides adjacent, opposite, and hypotenuse, we moved that triangle onto the Cartesian plane. I put my angle at the origin, and I placed the one side on the x-axis. The side opposite the angle we will now refer to as y. It looks like the y-axis. We're going to call it y. The side next to the angle is along the x-axis, so we're going to call it x. And we need a new name for the hypotenuse. But if I draw a circle around the origin with the center at the origin touching that triangle, then I have a radius, the line running from the center of the circle to the edge of the circle. So we're going to refer to the hypotenuse as r. So now we need to describe the trig functions with their new names. So sine theta will be y over r, and the definition for cos theta will be x over r, and the definition for tan theta is y over x. We need to look at the rest of the Cartesian plane and see how the trig functions are influenced in each of the quadrants. So if we first look at quadrant 1, x is always positive. On the right-hand side of my graph, my x values are positive. And my y values are positive because quadrant 1 lies above the x-axis. If we move over to the left into quadrant 2, the x values are negative, but the y values are still positive. If we move down into quadrant 3, it is where both x and y are negative. And moving back to the right into quadrant 4, x becomes positive again and y stays negative. Now we need to see how this influences each of our trig functions. What we need to remember though is r represents the radius. Radius is a distance, so the radius will always be positive. Now in quadrant 1, y is positive and r is positive. So a positive divided by a positive will give me a positive answer. So sine will always be positive. If we look at cos, x is positive in this quadrant and r is always positive. So a positive divided by a positive gives me a positive answer. So cos will also be positive. And with tan, both y and x are positive. So tan will also be positive. So what we notice is all three trig functions are positive in the first quadrant. Moving over to the second quadrant, if I look at sine, the y value is positive, r is always positive, so sine is positive in the second quadrant. Cos, however, x is negative divided by a positive gives me a negative answer. So cos will be negative in the second quadrant. And with tan, y is positive, but x is negative, giving me a negative answer for tan. So what we notice is only sine is positive in this quadrant. Moving down to the third quadrant, y is now negative. R is still positive, so sine will be negative down in the third quadrant. With cos, x is negative, r is positive, making cos negative in the third quadrant. And with tan, y is negative, x is also negative, and a negative divided by a negative is a positive. So out of the three trig functions, tan is the only one that stays positive. And moving over to the fourth quadrant, the y is negative and x is positive, which means sine is going to be a minus divided by a plus, so negative. Cos will be a plus divided by a plus, so positive. And tan is a negative divided by a positive, which is negative. So of the three trig functions, cos is the only one that's positive. What can we take from this is that all of them are positive in the first quadrant, sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. And this gives us our cast diagram. And we refer to quadrants 1, 2, 3, and 4. Now, how can we bring triangles into this? We need angles. So if we start with 0 degrees, we move up to 90 at the top, we go 180 if we move around, down to the bottom we get 270 degrees, and a full revolution is 360 degrees. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.